Hello, this is Dr. Hanaa Assil, and this is paper 1C of January 2020 in the Pearson Edexcel IGCSE. So let us discuss the questions. The first question said, this question is about gases in the atmosphere. The box gives the names of some gases in the atmosphere. Choose gases from the box to answer these questions. Each gas may be used once, more than once, or not at all. So the first question is, identify a noble gas. Which of these is a noble gas? Of course, if you don't know, you look at the periodic table. Where are noble gases? In group 0. So the ones available in that box is argon or helium. Both of these are noble gases. Then from the box, we're going to identify a gas that makes up about 78% of the atmosphere. Now, which of these makes up 78% of atmosphere? Remember that would be nitrogen, makes up 78%. Oxygen makes up 21%. Carbon dioxide is about 0.04%. And things like argon are about 0.1%. The next question says, identify a greenhouse gas. Which of these is a greenhouse gas? You should remember that greenhouse gases like carbon dioxide and methane, remember the ones we have are carbon dioxide or methane, these are gases that absorb the heat from the sun and traps it around the earth. So this causes what we call the greenhouse effect or global warming. Then he wants you to identify a gas produced by thermal decomposition of calcium carbonate. You should know that thermal decomposition means I'm going to break it up using heat. So if you heat calcium carbonate, what do you get? If we heat calcium carbonate, which is referred to also as limestone, this breaks up to give carbon dioxide as a gas and calcium oxide, which is referred to as lime. So the gas produced is carbon dioxide. Sulfur reacts with oxygen to produce sulfur dioxide gas. And he's saying write a chemical equation for this reaction. Again, I'm going to remind you, chemical equation means symbol and balance. So we want to write a symbol equation and balance it. What does he want? Sulfur reacts with oxygen. So sulfur plus oxygen. Remember that oxygen is diatomic, so it has to be O2 to give sulfur dioxide, that is SO2. Now, before you move on, you have to check that it is balanced. Is it balanced? Yes, one sulfur before the arrow, one sulfur after the arrow. Two oxygens before the arrow, two oxygens after the arrow. So as it is balanced. State an environmental problem caused when sulfur dioxide gas dissolves in water in the atmosphere. Remember we said gases like sulfur dioxide and nitrogen dioxide. When they go up into the atmosphere, they dissolve in rainwater and they form what we call acid rain. And of course, you should know acid rain is actually sulfuric acid or nitric acid. And of course, you should know that acid rain dissolves limestone in buildings, causing it to crumble. It kills marine animals and it kills plants. Okay, question 2 says the diagram shows the electronic configuration of an atom of an element. Now, complete the table by giving the missing information about this atom. The first question is, he wants the name of the part of this atom labeled Z. Of course, Z is the part that is in the middle of the atom, and that is called nucleus. Of course, please pay attention to spelling. Number of protons in this atom. How do I know? You should know that the number of protons would be the same as the number of electrons. How many electrons does this atom have? It has 2 and 8 and 2. So the number of protons would be the same number, and that is 12. Number of the group that contains this element. How do I know which group it is? The number of the group is the same as the number of electrons in outer shell. So how many electrons in outer shell? You have 2, so it is in group 2. The number of the period that contains this element. How do I know? This would be in which period? The number of the period is the same as the number of energy levels. So how many energy levels does it have? It has 3. It will be in period 3. What is the charge on the ion formed from this atom? If this atom forms an ion, what is it going to do? It's going to lose the 2 outermost electrons, and when it loses electrons, it becomes positive 2 or 2 positive. Okay? This element has 3 isotopes, and the table shows the mass number and percentage abundance of each isotope in a sample of this element. Calculate the relative atomic mass of this element. When he gives me the mass number and the percentage abundance of each isotope, how do we get the atomic mass? You should know that it is the mass number times the abundance plus the mass number of the other one times its abundance plus the mass number of the third one times its abundance, and we divide all that by 100. This gives me a certain number. Now, is this my answer? This is not my answer because he says give your answer to 1 decimal place. So please don't stop here. 1 decimal place would be 24.3. The diagram shows 2 samples of iron, A and B. Sample B is coated with a thin layer of zinc. Name the process used to coat iron with zinc. When we coat iron with a layer of zinc, that is called galvanizing or galvanization. The 2 samples of iron are left outside for several weeks. A brown solid containing hydrated iron 3 oxide forms on sample A. Of course, sample A is iron that is not protected in any way. It will become hydrated iron 3 oxide. What is the common name for this brown solid? Of course, what has happened to the iron? That brown solid is what we refer to as rust. So that is the common name. And if he's asking for the chemical name of rust, remember the chemical name of rust is hydrated iron 3 oxide. Give the names of the 2 substances that react with iron to form the brown solid. What does iron react with in order to form rust? It has to react with both water and oxygen. Iron can be formed by reacting aluminium powder with iron 3 oxide. The diagram shows how this reaction can be demonstrated. So he puts a piece of magnesium into a mixture of aluminium powder and iron 3 oxide. When the magnesium fuse is lit, a very exothermic reaction occurs. State the meaning of the term exothermic. What does exothermic mean? Remember that if I have a reaction and we say this is exothermic, that means it gives out heat, and the reactants inside the flask, they give out heat to what? They give out heat to the surrounding solution, so the solution becomes hot. Remember that an exothermic reaction gives out heat, and that means the reaction becomes hot and the temperature rises. The equation for the reaction between aluminium and iron 3 oxide is this. Explain what this reaction shows about the relative reactivities of aluminium and iron. Now, if I say aluminium plus iron 3 oxide, and there is a reaction in which the aluminium has displaced the iron, the aluminium pushed the iron out and replaced it. If aluminium displaces iron, that tells me that aluminium is more reactive than iron. So that is what this reaction can tell us about the reactivities. A metal that displaces another metal from its compound or its salt, then that metal is more reactive. Explain why the reaction between aluminium and iron 3 oxide is a redox reaction. Now, this question is repeated in almost every exam. If he's saying, I want to show that this is a redox, first thing you need to show that redox means I must have oxidation somewhere and I must have reduction. So we look at the equation, aluminium plus iron 3 oxide to give iron plus aluminium oxide. Now, what has happened to the aluminium? The aluminium has gained oxygen, that is oxidation. The iron 3 oxide has lost oxygen, that is reduction. So when we explain that this is redox, we say this is redox because the reaction involves both oxidation and reduction. The aluminium gained oxygen, and that is oxidation. The iron 3 oxide lost oxygen, and that is reduction. This question is about ionic compounds. The table shows the formula of some positive and negative ions and the formula of some compounds containing these ions. So he already wrote the formula of magnesium sulfide, aluminium sulfide. What about NH4 with S? Remember that NH4 you should know is ammonium. S2 minus is the sulfide ion. So how do we write ammonium sulfide? Remember that even if you don't know the valency of each one, the number of charges is the same as its valency. So ammonium has one positive, that means its valency is 1. Sulfur has 2 negatives, and that means that sulfur has a valency of 2. So I have to put 2 under the ammonium. The valency of 1 goes under the other. What about magnesium with nitrate? So magnesium nitrate, magnesium has a valency of 2, so I need to put 2 under the nitrate. Nitrate has a valency of 1, so this is the formula of magnesium nitrate. Aluminium carbonate, aluminium valency 3, the 3 goes under the carbonate. The carbonate has a valency of 2, so the 2 goes under the aluminium. Please remember the valency of 1 goes under the other. Then he says give the name of the compound with the formula NH4NO3. You should know that NH4 is ammonium, NO3 is nitrate. So this is ammonium nitrate. Sodium oxide is an ionic compound. Sodium and oxide ions are held together by ionic bonds. State the meaning of the term ionic bond. What do we mean by ionic bond? If I have ions, let's say for example sodium and chloride. The sodium has 1 electron in its outermost shell. It loses it and becomes Na+. The chlorine gains 1 electron, becomes chloride ion with 1 negative. Now, what is holding them together is called the ionic bond. So the ionic bond is actually the strong electrostatic attraction forces between the oppositely charged ions. I have positive and negative ions. They are oppositely charged. There is a strong attraction between them, and that is what we call ionic bond. The diagram shows the arrangement of electrons in sodium atom and oxygen atom. Draw diagrams in the boxes to show the arrangement of electrons in the ions of sodium oxide. So when these form ions, what does the sodium do? Remember, the sodium has one electron in its outermost shell. It will lose that electron, and he wants you to draw diagrams. Since he's giving you diagrams of all the electrons, then your diagrams also must have all the electrons. Usually we include only the outermost electrons, but here he wants all the electrons. So that diagram for sodium will lose its outermost electron, and that means it will have a positive charge. The other sodium ion is exactly the same. Remember, we need two sodium ions because oxygen has 6 electrons in its outermost shell. It needs 2. Each sodium can give only 1. So we need 2 sodium ions to give us 2 electrons. And when the oxygen gains the 2 electrons, now it's an oxide ion with 2 negative charges. Okay. Question 5. The boxes show the displayed formula of 6 organic compounds. Use the letters to answer these questions. And please try to follow any instructions he gives you. Use letters P, Q, R, S, T, and U to answer the questions. Each letter will be used once, more than once, or not at all. And the first thing he wants you to do is give the letter of the compound that is not a hydrocarbon. Remember, hydrocarbon means it has carbon and hydrogen only. So which one is not a hydrocarbon? Of course, the one that has bromine in there is not a hydrocarbon. So my answer is compound S. Then he says, give the letters of the 2 compounds that have the same empirical formula. What do we mean by empirical formula? Empirical formula is the simplest ratio between the atoms. So, what compounds will have the same empirical formula? Of course, if 2 of them are alkenes, for example, let's look at T and U. T is an alkene. Its molecular formula is C2H4. So if I simplify it, it becomes CH2. So its empirical formula is CH2. Now let's look at U. U is C3H6. So if we simplify it, again, its empirical formula is CH2. So these 2 compounds have the same empirical formula. Give the letter of the compound that's used to manufacture polypropene. If I want to make polypropene, that means I start with which one? With propene. Which one is propene? Yes, so that is compound U. Describe a test that can be used to distinguish between Q and T. Where is Q and T? Q and T. Q is an alkane and T is an alkene. So how do we distinguish between an alkene and anything else? Remember, the test is add bromine water. With the alkene, what should we see? With the alkene, it should become colorless. So, result with Q, what is Q? Is Q an alkene? Q is an alkane, so it doesn't react. No change, no reaction. But T is an alkene. Alkenes will change the bromine water from orange to colorless. Compounds P, Q, and R are members of the same homologous series. P, Q, and R are all alkanes, so they belong to the same homologous series. Give 2 characteristics of a homologous series. Remember, members of the same homologous series must have the same what? Same functional group, same general formula. If he wants a third one, we say same chemical properties. This is the displayed formula of an alkene. Give the name of this alkene. Okay, to name the organic compound, I need first to see how many carbons. This one has 4 carbons, so its name must be bute. It's an alkene, so it will end with ene. But where is the double bond? The double bond is after carbon number 1, so this is called bute, 1-ene. Now draw the displayed formula of another alkene that is an isomer of this compound. If I have bute 1-ene and he's telling me to draw its isomer, how do we draw the isomer? We said we can just draw exactly the same thing but with the double bond in the middle instead of on one end. So this has the same molecular formula. Remember, isomers are compounds with the same molecular formula, so same number of carbons, same number of hydrogens, but different structures. So instead of having the double bond on one end, we put the double bond in the middle. An organic compound has the percentage composition by mass of this. Show that the empirical formula of the compound is CH2F. So how do we get empirical formula? He gives me the percentage of each one. The first thing we do, divide by the mass number of each one. So the mass number of carbon is 12, hydrogen is 1, fluorine is 19. I'm going to remind you that the mass number is the big number in the periodic table. Now, I get numbers, I look at these numbers and I divide by the smallest. Which one is the smallest? 3.03. I divide all through by 3.03. I get a ratio of 1 to 2 to 1, and that means that my empirical formula is CH2F. Then he says the relative molecular mass of the compound is 66. Determine the molecular formula of the compound. Now, if I have an empirical formula and he wants me to get the molecular form, then the first thing I do is get the MR of the empirical that I just got. So the MR of CH2F is 33. But he's telling me that it shouldn't be 33, it should be 66. So I divide the 66 by the 33. I find that that means that the actual formula is twice what I got. So instead of having CH2F, we have C2H4F2. That is the molecular form. Okay? Question 6 says a student uses this method to investigate the reaction of dilute hydrochloric acid with zinc. So he says pour some dilute hydrochloric acid into a glass beaker, record the initial temperature of the acid, add a piece of zinc and stir the mixture, record the temperature of the mixture after 1 minute. And the first question is, write a word equation for the reaction of dilute hydrochloric acid with zinc. Please, if he's saying word, you have to give him word. Don't go and write symbol equations. And then if we react zinc with hydrochloric acid, what should happen? Remember that zinc plus hydrochloric acid will give the salt plus hydrogen gas. So this is the word equation. The diagram shows the thermometer readings for this reaction. Complete the table giving all values to the nearest 0.1. So you need everything in 1 decimal place. So where is the temperature after adding? Please make sure you're looking at the correct diagram. So the temperature after adding is the one on the right. So that is 22.4. The temperature before adding, that's the one on the left. If you read it, that is 17.7. Can you see that? And of course, the temperature change is just the difference between them. Also must be to 1 decimal place. Okay? Okay, another student repeats the method using 5 different metals to compare their reactivity. The student uses a polystyrene cup instead of a glass beaker. Of course, that is much better. If we are doing an experiment that in which we're measuring temperature, we should do it in a polystyrene cup, not in a glass beaker. Explain why a polystyrene cup is better. Remember that we should do it in a polystyrene cup because polystyrene is an insulator, so there will be less loss of heat to the surroundings. And that means the temperature that we measure will be accurate. Give 3 factors that the student should keep constant. Of course, when you read this question, you go back to what he was saying. What was he saying? He said, pour some dilute hydrochloric acid into a beaker. Record the initial temperature. Add a piece of zinc and stir the mixture. Record the temperature of the mixture after 1 minute. And he's saying he's going to repeat it using 5 different metals. So he's changing the metals. What should he keep constant? He should keep everything else constant. So he should use same volume of acid, same concentration of acid, and same mass of each metal. So these are the factors he should keep constant. The table shows some of the students' results. State why there is no temperature change for copper. So where is copper? Copper, the temperature change is 0. That means that when he put the copper in the acid, no change in temperature. Why? Well, we should know that copper is less reactive than hydrogen, so it will not react with acid. Remember that in the electrochemical series, copper is below hydrogen, and we said that means copper does not react with acid or with water. Predict the temperature change for iron. So I look at the table. You should see that copper is 0, iron, magnesium, tin, zinc. So what do you think is the temperature change for iron? Well, if we look at the electrochemical series, you should see that iron is less reactive than zinc. So it must be somewhere below the temperature change for zinc. At the same time, it should be above the one for tin. So it will be somewhere in between tin and zinc. So 4 could be a possible temperature change for iron. Now, from the table, deduce the order of reactivity of the 5 metals. Well, from the observation, he says copper, no bubbling. That means it is the lowest. Now, which one is the most reactive? The one that has what? Rapid bubbling. We have rapid bubbling with magnesium. And then what is next? The one for zinc says moderate bubbling. And then slow bubbling for iron. And then very slow bubbling for tin. And we said copper did not react at all, so it is the least reactive. This question is about some of the halogens and their compounds. You remember the appearance of halogens and the state of the different halogens. So if he says which element is a liquid at room temperature, remember we said which halogen is liquid. It is bromine, of course. It is a reddish brown liquid. And remember that bromine is the only liquid non-metal. Which element has the palest color? Well, you should realize the one on top, fluorine, that is the palest color, but we don't have fluorine in the choices. We have chlorine, so that would be the palest among these. Remember that fluorine is a yellow gas, chlorine is a green gas, bromine is a reddish brown liquid, iodine is a gray solid, and astatine is a black solid. So as we go down group 7, the color gets darker and the state goes from gas, liquid, solid. Which element is least reactive? What is happening to the reactivity? Remember that reactivity in group 7, the one up is most reactive. So he's asking for which one is least reactive in that list. As we go down, reactivity decreases. So in that list, astatine is the least reactive. A teacher uses displacement reactions to demonstrate reactivities of some halogens. She adds solutions of chlorine, bromine, iodine separately to 3 different sodium halide solutions. Again, we're going to say in group 7, the one on top is more reactive than the one below, and that means the one on top is the one that will displace anything below. So if we add chlorine solution to sodium bromide, the chlorine is more reactive than bromine, so the solution turns orange. This is because the chlorine displaces the bromine and bromine solution is orange. What if we add chlorine solution to sodium iodide now? We should know that chlorine is more reactive than iodine, so it will displace it. Iodine solution will cause the solution to turn brown. Now, the one that we're supposed to complete is iodine solution with sodium chloride. If iodine is added to sodium chloride, what will happen? Remember that iodine is less reactive than chlorine, so it cannot displace it. So the color of the iodine solution remains and the iodine solution is brown. So the solution stays brown. Also iodine with sodium bromide, also the solution stays brown. So please follow his examples. Okay. Then he says, state why the teacher does not add bromine to sodium bromide. Of course, we don't add bromine to sodium bromide or chlorine to sodium chloride. This is because the halogen cannot displace itself. So bromine cannot displace itself. The word equation for the reaction of bromine with sodium iodide is this. Of course, bromine is more reactive than iodine, so it displaces it. And he gives you the word equation and he wants you to write the chemical equation. So remember, bromine, iodine, all of these are diatomic. Sodium iodide, the valency of sodium is 1 and valency of iodine is 1. And we have to balance. So if I have 2 bromines before the arrow, I need 2 bromines after the arrow. If I have 2 iodines after the arrow, then I need 2 iodines before the arrow. Please remember to balance before going on to the next question. A technician sees an unlabeled bottle containing a liquid. He knows that the liquid is a solution of one of these compounds. So either it is copper 2 chloride, copper 2 bromide, or iron 2 chloride, iron 2 bromide. Describe chemical tests that the technician could use to identify the compound in the solution. So what can we do? He's telling me that it can either be copper 2 or iron 2. How do we distinguish between them? Well, we can use sodium hydroxide solution. So I can tell him add sodium hydroxide solution to each of these. If I have blue precipitate, that will indicate that I have copper 2. If I get a green precipitate, that indicates that we have iron 2. So once we have decided is it copper or iron, we need to decide whether it's chloride or bromide. So to test for that, we have dilute nitric acid, aqueous silver nitrate. We said if we add these 2 halides, a white precipitate indicates chloride, cream precipitate indicates bromide. So remember that silver nitrate, chloride gives white precipitate, bromide cream precipitate, and iodide yellow precipitate. Carbon dioxide changes directly from a solid to a gas without becoming a liquid. Give the name of the change of state from solid to gas. You need to know the names of these change of states. So from solid directly to gas or from gas to solid also, we call that sublimation. And you should be familiar with the other changes of state. Describe the test for carbon dioxide gas. What was the test for carbon dioxide gas? Bubble the gas through lime water, it turns milky. Carbon dioxide is a simple molecular covalent substance. Explain why carbon dioxide turns from solid to gas at a very low temperature. So basically, he's asking you to explain why carbon dioxide has a very low melting point or sublimation point. Remember that when we have simple molecular structure, they usually have low melting and boiling points. Why is that? That is because they have weak attraction forces between molecules that need a small amount of energy to be broken. So if he says anything has low melting point, it is due to weak attraction forces between molecules that need a small amount of energy to be broken. Diamond and graphite are both giant covalent substances made up of carbon atoms. And he's saying diamond is used in cutting tools, graphite is used in pencils to make marks on paper. Explain with reference to structure and bonding why each substance is suitable for its particular use. Now, if we use diamond in cutting tools, that is because diamond is hard. And why is it hard? Because it has giant three-dimensional tetrahedral structure. It has many strong covalent bonds between the carbon atoms. So this makes it very hard, and that is why it is used in cutting tools. So remember that when we're talking about the structure of diamond, diamond is giant three-dimensional tetrahedral structure in which each carbon atom is covalently bonded to 4 other carbon atoms. So it is giant and it has many strong covalent bonds, and that makes it hard. Now, graphite, he's saying, is used in pencils to make marks on paper. That means it is soft. So why is it soft? It is soft because there is weak attraction forces between layers that allows them to slide over each other or slide past each other. Please remember how to explain all of this. Question 9 says a student uses this apparatus to investigate the heat energy released when a liquid fuel is burned. This is the student's method. Measure the mass of the spirit burner and fuel. Add 100 centimeter cubed of water to the copper can. Record the initial temperature of the water. Use the spirit burner to heat the water until the temperature rises by 30 degrees Celsius. Immediately measure the new mass of the spirit burner and fuel. And he's saying suggests why the student measures the mass of the spirit burner and fuel immediately after heating the water. Of course, as soon as we have finished heating, we need to measure the mass very quickly to avoid any decrease in mass due to evaporation of the fuel. If I leave it for some time, more of the fuel will evaporate, so the mass that I measure will not actually be correct. When the fuel is burned, the student notices that a black solid forms on the bottom of the copper can. Identify the black solid. Remember, when we burn something, there can be incomplete combustion. So let's say we're burning this liquid fuel. If it does incomplete combustion, then in addition to carbon dioxide and water, it would give other products like carbon monoxide and carbon. So the carbon solid is the black solid that forms when there is incomplete combustion. So he's saying identify the black solid. The black solid is carbon. So this is the soot or the black stuff that is seen when something burns. Explain why this forms. We said carbon or carbon monoxide forms due to incomplete combustion of fuel when there is limited amount of oxygen. When there is not enough oxygen, then the fuel will burn by incomplete combustion and it will form carbon or carbon monoxide. Show that the heat energy change Q to raise the temperature of 100 centimeter cubed of water by 30 degrees Celsius is approximately 13 kilojoules. So basically he's telling you to calculate Q. How do we calculate Q? You should know that Q is mc delta T. What is M? M is the mass of water, and we said that is the same as its volume because density of water is 1. So the mass of water is 100 grams times C, which is 4.2, times the delta T, which is the temperature change. This gives the energy in joules. He wants it in kilojoules. He's saying show that it's approximately 13 kilojoules. Yes, it is 12.6 kilojoules. That's we divide by 1,000, of course, to change from joule to kilojoule. The student burns 0.96 grams of methanol. Calculate the molar enthalpy change delta H. So how do we calculate delta H? You should know that delta H is Q over N. So I need to calculate N first. Number of moles is mass over molecular mass. The mass of methanol over its MR. This gives me the number of moles. And then delta H is Q over N. So the Q that we got up there, 12.6, over the number of moles, that gives me a value of delta H in kilojoules per mole. Remember, delta H must have a sign. How did I know that the sign is minus? Because this is combustion. Combustion is an exothermic reaction. Delta H must be negative. The table shows data book values for the molar enthalpy change, delta H, for the combustion of some alcohols. So he compared alcohols with different number of carbons and determined their delta H. Plot the data values from the table on the grid and draw a straight line of best fit. So he gives you the grid, you plot the points, we're going to find that the points look like this, and draw a line of best fit. We don't need to join it to the 0 mark. So this is the line of best fit. Straight line means with a ruler. Then he says deduce the value of delta H for an alcohol with 6 carbons. He did 4 carbons, 1, 2, 3, 4, and 5. So he's saying from the graph, determine if something has 6 carbons, the delta H will be what? And that means we extend the line and determine for 6 carbons. So that shows from the graph that delta H is minus 4,000 kilojoules per mole. Please show on the graph how you obtained your answer. So you have to draw these lines that I drew in red. State the relationship between delta H and the number of carbon atoms. So looking at the graph, obviously, as the number of carbon atoms increases, the delta H is larger. Remember, it's a negative number because it's exothermic, but the numbers are larger for larger number of carbons. Nitric acid is used in the production of fertilizers. Nitric acid is manufactured in 3 stages. So he's saying in stage 1, we're going to react ammonia with oxygen in presence of platinum catalyst to produce nitrogen monoxide and water. And then in stage 2, the nitrogen monoxide reacts with more oxygen to produce nitrogen dioxide. And then the nitrogen dioxide gas reacts with water to produce nitric acid and more nitrogen monoxide. First, complete the chemical equation for the reaction. So we need to balance. How do we balance this? We count the number of atoms before the arrow and after the arrow, and we increase the one that is less. So if I look at, we have one nitrogen before the arrow, one nitrogen after the arrow. How many hydrogens before the arrow? I have 3. After the arrow, I have 2, so I need to increase the one that is less. So I need to put a 2 here. But this makes my hydrogens 4 after the arrow, so I need to increase that one also. And that means I have 6 hydrogens before the arrow and 2 nitrogens, so I need to continue. Now I have, the problem here will be the oxygen, because now after the arrow I have 2 and 3, so that's 5. So we don't like to have fractions, so we're going to multiply everything through so that this will be the final balancing of the equation. Please keep going until all the atoms are balanced. Give the meaning of the symbol. Of course, this symbol means that the reaction is reversible. State the purpose of the platinum catalyst. Of course, the platinum catalyst, he says ammonia reacts with oxygen in presence of platinum catalyst. Any catalyst is added to speed up the reaction. Give a chemical equation for the reaction of nitrogen monoxide and oxygen in stage 2. He's saying in stage 2, nitrogen monoxide reacts with oxygen to give nitrogen dioxide. He wants a balanced chemical equation. So when you look at this, you will need to balance the oxygens and the nitrogen. So this will be my balanced chemical equation. The equation for the reaction in stage 3 is this. Calculate the mass in tons of nitric acid that could be produced from 11.5 tons of nitrogen dioxide. So he's giving me information about nitrogen dioxide. I need to get the number of moles. Please remember, we do not work in tons. We have to change it to grams. So 11.5 tons is 11.5 times 10 to the 6 grams. Over its MR, that gives me the number of moles of nitrogen dioxide. Now I look at the equation and I relate the number of moles from the equation. From the equation, 3 moles of NO2 gives 2 moles of nitric acid. So the number of moles that I have will give how much? So the number of moles times 2 over 3 gives me the number of moles of nitric acid. And then what is he asking for? Mass. How do we get mass? Mass is number of moles times MR. And what I get it in grams. And he wants it in tons. So I need to divide what I get by 10 to the power 6 to get my answer in tons. Okay? So just what use can be made of the nitrogen monoxide gas formed in stage 3? So in stage 3, he says nitrogen dioxide gas reacts with water to produce nitric acid and more nitrogen monoxide. So what can I do with that extra nitrogen monoxide? Well, if you go back to stage 2, you will find that he's using nitrogen monoxide. So I can reuse it in stage 2 to make more nitrogen dioxide gas. The last question, when copper 2 oxide reacts with dilute nitric acid, copper 2 nitrate is produced. The equation for the reaction is this. And he's saying I'm starting with 0.2 mole of nitric acid, a mass of 15.3 grams of copper nitrate is produced. Calculate the percentage yield. How do we get percentage yield? You should know that we calculate the mass that he should get, and then I can calculate the percentage yield. So he's starting with 0.2 mole of nitric acid. Well, he's asking about what? Copper nitrate. That means that the number of moles from the equation relating nitric acid to copper nitrate, the number of moles of copper nitrate is half the number of moles of nitric acid. Then he's asking for mass. the mass of the copper nitrate will be number of moles times MR. He already gives me the MR. So theoretically, he should get 18.75 grams. But what did he get? He got 15.3. So the percent yield is the 15.3 over what he should get times 100. That gives me my percentage. Okay, I hope this was useful to you. Please study all of this, and thank you for listening.